Today is the 23rd. It's going to be February in like 7-8 days. I don't even know what to say about it. So to this point, yeah, I know it's crazy, huh? To this point, we have gotten pretty good at solving quadratic equations. By the way, this isn't like me going backwards because I feel crazy. The unit that we're about to head into, part of this, and you won't see this for probably another at least few days, maybe a week, is that we're going to want to convert quadratic functions that are in standard form into quadratic functions that are in vertex form. And the only way to do that is to use a skill called completing the square. So I figured we'll kill two birds with one stone here. We're going to focus for a couple days on just how to solve a quadratic equation using this particular method. And then later, when we need it, we'll have this method in our back pocket so that when we have to convert vertex or standard to vertex, then when we get to the whole, move this, half of this, square this, put this, then we'll, the algorithm will always or already kind of be stuck in our heads. That's the plan. So, yeah. So anyways, just a quick recap of what you already know. If I gave you a quadratic equation like this, and again, this is all old stuff right now. Okay, so this is not today's lesson. This is just a kind of a broad, big picture of where we're at. So you know how to solve a quadratic like this. If I said to do it by factoring, we're going in the way, way back machine here, like to September. If I said to solve this by factoring, then you would of course say, okay, it's set equal to 0, check. And then this is pretty light work as far as factoring is concerned, right? You would just factor it down like that, right? Easy peasy. And then if the factors are x minus 6 and x plus 2, then the roots or the zeros or the solutions of this equation would be x equals positive 6 and x equals negative 2. That should be just right there. It's a little dusty, perhaps a couple file drawers in, but you remember that, right? Okay, so that's which one? This one right here? Here, I'll fix it for you. How's that? So you remember that method, right? So we're not going to talk about that. That's not what we're doing. I just wanted to give you that sort of background perspective. Another thing that you already know how to do is to solve using the quadratic formula. So we might have something like, x squared plus 5x minus 11 equals 0. And as I tried to teach you, we look at a quadratic like this, and it doesn't take us long to figure out that factoring ain't going to happen, right? You're not going to break this down. And so this is where we would have gone to our quadratic formula, right? Negative b plus or minus the square root of b squared, blah, 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 blah. So we've been down that road many times before. So that's where we're at right now, is I feel like 2 down, 1 to go. And so the third method for solving quadratics is the one that's my favorite, quite frankly. I mean, factoring is nice because it's quick, but honestly, all things considered, this one feels so beautiful and elegant. And once we get this out, I can actually, if you're interested, it's a heavy lift, but if you're interested someday, I can show you after today's lesson where the quadratic formula comes from. It's, sometimes kids think like it was invented by some guy with a long gray beard in a cave, with some Greek name or something. And it's not like that. It's like anything in math, things don't get created as much as they just sort of evolve and get discovered. And so after today, you'll know, if you want, I can show you where the whole obscure quadratic formula actually comes from. It's really neat. It's just not something that we'll talk about today. It's kind of cool. So anyways, I have a bunch of examples on the docket here, 7 of them. I don't know if we'll need all of them, but 8 actually. So here's our first example for today. So we have x squared plus 20x plus 75. And everything today, I'm just going to already have it preset equal to 0. So we're not going to have to deal with moving or combining terms. It's just going to be ready to rock and roll. So I'm going to show you the algorithm for how to complete the square. You 9th graders who I had last year in Algebra 1, We might have done this last year. I don't think I do this every year in Algebra 1, but like Gabe, Sutter, Swaggy B, Sebastian, that it? This might ring some bells. 1 year to the next, completing the square. You do have it? Nice. So here we go. It's not hard, but I love this method for completing or for solving a quadratic. First off, we're not going to check today for factorization. This one actually turns out to be factorable, just FYI, but that's not what we're going to look for. We're going to spend today and tomorrow just hitting this process, this algorithm over and over again and getting it just like stuck into our heads. How do I complete the square? So here go the steps. Ready? Okay. So step one is you're going to leave your x squared and your 20x on the left-hand side. You're going to clear a space and you're going to move the 75 to the right. Like this, which I know feels pretty weird, but trust me on this one. Yeah, you always leave your quadratic and linear terms on the left and then move the constant term to the right. And notice that I left a space there. Again, it's not because I'm losing my mind, although I think sometimes that I might be. This is not indicative of that. That space that I left is on purpose. So what we're going to do is something called completing the square. And to complete a square, if you think about it, I'm going to make a new page here and just kind of go on a little detour. Imagine I asked you to factor this. Okay, let's not imagine. I'm asking you, help me factor this, please. What would it factor down into? 3 and 3. In other words, it would be x plus 3 times another x plus 3. But at this point in time, we 100% need to think of it like this. X plus 3 squared. Got it? This is a really neat thing that this thing exists. This thing, by the way, is called a square. I know it looks like a rectangle, but I'm not talking about the red box. I'm talking about what's in it. Anything that is to the second power is by definition called a square, right? So my goal is to identify squares, and when I don't have one, to make one. Let's practice the factoring process a couple more times. Again, these aren't just normal factoring problems I'm asking you to do. What's that? Yeah, -7 and -7. So this one factors into x minus 7 times x minus 7, which, yeah, let's get right to it. It's x minus 7 squared. So once again, what we've seen is that that thing is called a square. And by the way, this is also called a square. Okay, it's the result of x plus 3 squared. So that's what we're trying to do here is we're trying to figure out how can I be the one who makes a square? That's why we call it completing the square. So I give you an incomplete square and your job is to complete it. So let's say I put in here x squared plus 12x and then I put a blank here. Again, ninth graders, this will probably be a little bit more fresh for you, but the magic number is 36. And you might wonder like, well, how do I get that? And how I get that is by just following an algorithm, steps, process. What is half of 12? Good. And what is 6 squared? So if you put a 36 here, then you do something called completing the square. You just made a square. And I say that because now this red and white thing up here, if I were to factor it, what does it factor down into? X plus 6 times x plus 6, which of course is x plus 6 squared. So the act of adding that red number, and I'll be pretty consistent with that color of red. You'll see red over and over again. That red number is the number that completes the square. By putting a certain number there, you make it so that that thing factors down into a binomial squared. It's not just some random number selection. It's very deliberate. All right, let's do it again. 100 is our guy, right? And the algorithm again is just one that you just follow it. You don't question it, you just follow it. What's half of negative 20? Negative 10. And what's negative 10 squared? So 100 is the magic number that completes the square. And again, we call it a square because when you factor it, it factors into x minus 10 times x minus 10. Got it? So that's the terminology completing the square. I mean, it's logically, I mean, it fits. You're literally putting a number that completes a square. So back to the other page. So when we look at this problem now, what we want to do is, and I've cleared that little landing strip there because what I want to do is I want to put a number in there that completes the square. Ignore the right side now. The negative 75 can just wait, right? But I want to complete the square right here. I want to make a square. What's half of 20? What's 10 squared? Now, as you know from the old days, like way back, is that in math, if you do something to one side of the equal sign, you do the exact same thing to the opposite side, right? So I have to go to the right side, and I also have to add. That's Algebra 101 right there, right? That's not a Mr. Ahern thing. Now, hope I'm not going too fast. This thing I've underlined in red is a factorable square. The 100 made it a square. What does it factor down into? Right. And I will tell you that I spend a lot of time and energy every year trying to convince people or to teach people as to where did this number come from. And I have two answers for that. Number one is get good at factoring, right? But answer number two, maybe a little less snarky, is it's really simple. I'm going to go back and color code this. What is half of plus 20? Plus 10. That will always be the number that goes into your parentheses when you factor a square. Got it? Remember this? Okay. And now on the right side, I got to do some fourth grade addition. What's negative 75 plus 100? It is positive 25. You guys with me so far? Yep. Good. Now, to solve an equation like this, you just have to take the square root of both sides. And so on the left side, when I take the square root of a square, so I'll just kind of illustrate this for you with some little purple square root signs. When I square root the left side, nothing exciting happens. All that happens is the purple root sign and the exponent are just offsetters. They just poof away. So I'm left on the left with x plus 10. And on the right, I'm left with the positive and negative of the square root of 25, which would be 5, right? I'm going to cross that bridge in a second. What I wanted to talk about in this step, though, is this is the moment in time. You guys are a great group this year. Put this down. This is the exact moment in time where you have to add the plus or minus or the positive negative sign. And that happens the moment you take a square root like that, then you have to incorporate the positive or negative consideration of that number on the right. Okay. So put that in your notes and draw it right there, not a moment before, not a moment after. That's the point in time when you positive negative the right-hand side. Now, like Bryce said, let's cross that bridge and let's analyze now that square root on the right. You've heard me say this before. There's a lot of options. If you get something like this, then yeah, it's just 5. But sometimes you get something like the square root of 20, which you would just break down. Sometimes you might get the square root of 5, which you can't break down. And sometimes you might get like the square root of negative 8, which you would break down, but also have an eye with, right? We have all those tools at our disposal now. So we're going to look at the square root of 25 and say, well, I know who you are. You're just 5. So I'm going to take off this square root of 25, and in its stead, I'm just going to put a normal 5. Not a root 5. Man, do I hate it when people do that. Just a 5. You still with me? And then, of course, to finish the job, and we're not quite done with this one. These are the most annoying ones because when the root goes away, you always have more work to do. But to finish the job, what you need to do now is take this 10. I should switch colors here. I want something that stands out. Let's do green. This 10 is going to relocate to the other side, and it is going to go right where that green arrow is pointing. It goes immediately in front of your positive negative sign, thereby switching it into what we call a plus or minus sign. So when I rewrite my answer now, I have x equals negative 10 plus or minus 5. Now, there will be times when you would stop here because the 5 could be like the square root of 3. Let's just say hypothetically that I got to negative 10 plus or minus the square root of 3. Done. Right? But like in a case like this, what the math gods would tell you is that if there's math to do it. That's what the word simplify means, is if there's math, you go. And of course, there is math to do here, right? There's 2 pathways, I like to say, pathway problems. And so I view this as a plus pathway and a minus pathway. So they're color coded. Let's do the red pathway first. What is negative 10 plus 5? It is -5. So one of my answers is -5. And of course, if I take the yellow pathway, what's -10 minus 5? Good. So again, for you ninth graders, that's probably more of a nice brush up review. For you 11th graders, it's probably like either it's been a long time or I've never seen this before. Either way, this lesson is being taught with the assumption that you've never done this before. So good. Okay, let's go again. So we want to get really good. You know how I teach math. I teach math by encouraging you to practice math. And so let's get good at the steps by just hitting them again and again and again. What is step 1? Move the 37. Good. Clear that landing strip. Clear that landing pad. So we want the x squared, the quadratic term, and plus 10x, the linear term, to just stay. We're going to leave an awkward void, basically just the equal sign, just bring it straight down. And then the 37 becomes a -37, right? Now the landing pad is open and we follow the algorithm. The algorithm will never fail you. Never. What is half of plus 10? Plus 5. What is plus 5 squared? So I will add 25, and then to not get struck down by the math gods, I would, of course, then say, whoa, hold on, I was about to do it. I'm going to go to the other side and add 25 as well. Do it to one side, you do it to both sides. What I have underlined in red up here is called a square, and it's my job, your job, to be able to factor that square down. So what does it quickly factor into? X plus 5 squared. And again, you eventually, maybe not you, but a lot of you are going to ask, I don't understand. How did you get the 5? And I will continue to say, it's the answer back there to the question of what was half of plus 10. Got it? So I write it down sometimes, honestly, at this level, algebra 2, I probably won't keep writing it down every time. But like if you say to yourself, what's half of plus 8? Write down plus 4. That's going in your parentheses. You don't, I think I said this in algebra 1. You don't even have to know how to factor to do this. You're factoring, you just don't have to know that really that you are, because the algorithm won't fail. And then on the right side, here we go again with some little kitty math. Oh boy, what's -37 plus 25? And we've arrived. Now what do we do to both sides? Square root both sides. When I square root the left side, what do I get? Yeah, no parentheses anymore, right? The parentheses were only there to enclose the squaring process. If the squaring process is gone, they're not needed. Don't put them, they'll confuse you. Equals positive, negative. Thank you. It's the first thing I need to hear is positive, negative. If you don't say that, I'm going to cloud up and rain on you. Positive, negative gets inserted right then. Now we can worry about that root thing. So let's talk about this. It's been a minute since we worked with radicals. Tell me something about the square root of -12. It's going to have an I in it. And how does just a regular 12 break down? Into a 4 and a 3. And what does the 4 become? So my 2, and then I wedge an I in the center, root 3. So I'm gonna put right here where I'm moving my pen, I'm gonna put 2I root 3. That will be your job at that point, is to deal with that root. Sometimes if you're lucky, it'll be like the square root of 37. You're like, done, right? And then you get ones like this that are a little more annoying. Oh well. The last step. Yeah, move the 5 over, right? And remember that we are not negotiable on this. The 5 will be placed right there, just after the equals and just before the positive negative sign. And the verbiage changes. I will always say this every year, and I will try to only say it once and not be all over you and get all micromanagey. I'm going to point to a symbol right now, and I want you to read it to me. That red arrow, what does that say? It doesn't say plus or minus. It says positive, negative. And I use the logic of this. Here's a number. Ready? Read it to me. What does that say? Right. Only the weatherman can get away with saying it's -4 outside. Like we all know that that's not proper. That's a -4, right? But now read me the red expression, right? We don't say 10 -4 anymore. So like the verbiage that we use has to change depending on whether there's something in front of a negative sign or a positive sign. So when I point to it up there, and I'm not going to just I'm saying this so I can sleep better tonight. If there's nothing in front of it, it's a positive negative sign. If there's something in front of it, the verbiage changes to plus or minus. So once I move the 5 over, it's going to look like this: -5, that sign, 2i√3. And now green arrow, when I point to this sign, what is it? Yeah. Do I really care? Not that much. I just figured 45 seconds. Now we know. So positive, negative switches to plus or minus. And we're done. At that point, these are the final answers. So good. Any questions so far? This is all about steps. It's all about just boom, boom, boom. 3, 4 steps, same things in a row every time. Let me ask you right now, 11th graders, did we do this a couple years ago? Is this ringing any bells? IDK, bro, it's been too long. Okay, so it's just a little, I know it's a lot to ask. I barely remember what I had for dinner 2 nights ago, so I shouldn't expect you to know what we did 2 years ago. Let's try this one. Houston, we have a problem. Something stand out? Yeah, honestly, -4. Listen, add this to your notes, please. If you'd be so, if you're a note taker, add this. You need this to not have anything with it. I don't know how you want to phrase that, but you can't have a number attached to that. And that's a lie. You can, but trying to do this process, oh, nightmare. So what we're going to do is at any cost, when we see a quadratic like this, we're going to divide away whatever the leading coefficient is. And because we're warming up today and probably tomorrow, I'm not going to give you nasty ones. You'll notice in this case that to get x squared by himself, we got to divide by -4. And it just so happens that all the other numbers in the problem are like, hey, we play along. There will come a point where not everyone agrees to play along. But I don't care. I'm not going to change my plans because there's a number somewhere else in the problem that says, I won't divide by -4. I'm pressing on. I'm going to, at any cost, get the yellow thing by itself. So yes, we are going to divide here, and I won't show this every single time. I'm just showing it so you know what we're doing. We're dividing everything by -4. And you don't need to think of it as like a GCF because in this case, well, I wonder. Yeah, for now, we could just divide it away, just trash it. So when we divide by -4, we're going to get x squared, and then what? Plus 4x plus 54 equals, of course, 0. And then the algorithm resets. All is right in the world. So let's go through these steps again, and then you'll get to practice. We'll do maybe 1 or 2 more examples, and then just practice, 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 practice. Step 1. Move the 54, subtract the 54. Like either one of those is a good way to say that. So x squared plus 4x, awkward void equals, and now -54, right? Totally familiar? Okay, good. And then we follow the steps. Half of +4 is +2. What's +2 squared? 4. So I'm going to add 4, and of course, I'm going to add 4 here as well. And then I'm going to factor the left side down. This is my square. Doesn't look like a square. It's a square. And when I factor it, it factors into x plus 2 squared. And then the right side, you do get -50. You see how crippling it is in my line of work when some knuckle mouth breather says -58, right? It's like, oh my God. So yeah, we made it. And now what do we do? Square root. Let's root both sides. Left side becomes just normal x plus 2. And what do I put right away? positive, negative. Got to insert it. And then we got to take the square root of negative 50. Definitely 5i root 2. Good. You know, it'd be boom, 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 boom. If you're a little slow at that, that's okay. Just show your work until maybe you kind of reacquaint yourself with the process. Remember that we broke it down into a 25 and a 2, and then the 25 changed into a 5. So I'm going to put that there. And then the last step. Good. One more. Okay, that'll, I think, have us at 4 or 5 examples as opposed to 8. As with anything, the best way to really get it isn't to sit here and listen to me drone on. It's going to be just get in there and practice. So let's do one more. And I don't know what the outcome of this one's going to be. This is a surprise. I just put this one on here because I thought it looked fun. By that, I mean, we'll see. This skill, this process that we're trying to get stuck in our heads today and tomorrow will be hugely beneficial. You'll see when we get to graphing parabolas. Promise. So what do we do? No, you can, but no, I would rather. Actually, you want to do 2 things at once. I'm down, but let's divide everything by negative 5. And be careful. I probably wouldn't do them actually. Did you say x2? Okay, so x squared. Okay, so x squared plus 16x. And I'm not feeling very bold. I'm going to leave this where it's at, right? Plus what? 309, you say? I think so, yeah. 1,500 divided by 5 is 300, and 45 divided by 5 is 9. Makes sense to me. I think that if you try to do those 2 steps at once there, you might run into an issue with the double sign change. Like we had to change the sign when we divided it, but then we have to change it again. And some people can conquer that. Some people might go, that was a lot. So you got it. It's pretty. Definitely. It's never negotiable. Half of plus 16 is plus 8. And positive 8 squared is positive 64. So 64 is our dude. We're going to add 64, and we're going to add 64. Factor. My 3rd favorite F word, factor. I can't tell you the other ones. I'll tell you my 2nd favorite is fraction. So yeah, the 2nd is fraction. You already know the first. What does it factor down into? X plus 8 squared. Dope. Gorgeous. Perfecto. Now what do we do? Take the square root of the both sides. Gives the x plus 8. This one's rough. Negative 245. We know, like Kinsley said earlier, it's going to be an I in it. I know that much. How do you break down a 245? 9 won't go into it, and you can't make it with quarters. Yeah, 49. Yeah, I love your mental math prowess, Coop. That's some pretty powerful stuff you're doing there. So yeah, the square root of 49 and the square root of 5. Excellent stuff. I love how you do that. So that's going to be 7i root 5. Positive, negative 7i root 5. The only other thing I want to say before I conclude the notes is let's practice just a couple ending pathway problems real quick. So I probably could have put more of them in my examples, but like these are nice because you'll just kind of know when you're done, right? But let's talk this. Let's just hypothetical say we got to the end. We're not going to do the whole process. Let's say we got to the end and it said x equals negative 4 plus or minus the square root of 36. This is a pathway problem, and why do I know that? because it's an actual square rootable number, right? So as soon as the square root vanishes, these are the ones you should probably hate the most. I'm not telling you what to like and not like, but generally when it involves more steps, we're going to like it less, right? And so the fact that the square root of 36 becomes a regular number is just more work for us, isn't it? So now I got to trace my pathways. Come on in. We're almost done, okay? Just give me like one more minute. So you guys understand what I mean, right? So let's take the red pathway. Basic math, what's negative 4 plus 6? Good. And so when you're in delta math today, remember that there's going to be, oh, by the way, the other one, what's negative 4 minus 6? Good. So just, we're a little rusty here. Remember that with delta, when you go to submit your answers, you know how there's always just the one box? So you would put 2 in this one, but do you remember how to get a second answer box? You can put you could type, if I type a comma, Delta will interpret that as here's another box. There's also another, they updated Delta Math, and there's actually a little thing now that says like add additional answer or something like that. It used to be a little plus sign, but now I think it's actually pretty logical. So any questions, guys? All right, it's on Delta. You got this. This is definitely an on paper assignment, so you're done. I'm going to pause the recording, so if you guys have any questions, I can get them onto the recording. I don't know who will have this question or if you would have this question, but a great one just came up. When you get to the end, if you had like negative 6 plus or minus the square root of, I don't know, like negative 100. I think this is a valid question because it feels like it could be a pathway problem because we love the number 100, right? Because it can be square rooted. So this feels like maybe I could go further. I get negative 6 plus or minus 10, but I have to have an eye on it. That renders this done. I need you to understand that these terms are not like terms anymore, right? Like the I makes it so that they can't go together. So even though the square root of 100 felt pretty rad, it actually was the square root of negative 100. So this is a completed answer. So good. Excellent question.